We're going to be solving simple equations today, but before we can actually get there, we need to define some vocabulary words that we're going to use throughout the year to make sure we're all on the same page. So the first thing we're going to do is define parts of a term. This is considered a term. It would be like adding or subtracting things on either side of it, but this creates a term. There are three parts of a term. You have the coefficient. The coefficient is the big number that's in front of a term. So if we had a term 2x cubed, the coefficient would be 2. It's the big number multiplied in front of a term. That tells you how many times that term shows up. It's multiplication. The second part of a term is the base or the variable. And I'm going to shorten the word variable to vars. That's the mathematical shortening for the word variable, vars. This is the x or the y or whatever letter you're using. It's considered the base or the variable. The third thing you have is called an exponent. Exponents are small. They're superscripts, so they're written up above. It's like sitting on the shoulder of the base or variable. You may also hear this called its power. So you have three parts. You have a coefficient, a base, and a power. 2x cubed has a coefficient of 2, a base or variable of x, and an exponent or power of 3. Now we're going over parts of each term because we are going to need to combine like terms. To combine like terms, we are going to have to find the like terms, and these are pieces of an equation or expression that have the same base and the same exponent or power. So we're looking for things with the same letter and exponent. The first little part of your notes here asks you to circle the like terms in each box. So if we're looking at this first box, there are three things that are like terms. The first two that are like are x and 5x because they have the same letter of x and the same power of an invisible 1, aka you don't see a power. There is one more thing that is a like power with it. What is that like term? Negative 1/4 x is a like term because even though it has a quote-unquote complicated coefficient of negative 1/4, it still has the base and the power that we're looking for of x and an invisible 1. In the second box, there are only two terms that are like terms. And remember, since we're looking for the same base and power, we are looking for the like term with 2/3 x cubed. Well, that's 15x cubed. Even though this right here has the same coefficient as the first term that we circled, it does not make it a like term because it has a different power. Okay? Base and power make like terms. So if we're wanting to combine our like terms, combining like terms is simply asking you to add the coefficients of the term with the same base and power. Now you may be adding negative numbers, but you are always combining them, adding them. Another vocabulary word we need to define before we get started is inverse operations. You may have heard of this one before. Inverse operations are mathematical operations that undo each other. They're opposites. So the addition is the inverse of subtraction, and multiplication is the inverse of division. There are some other inverses in the math world, but these are the four that we're going to use today. Okay, if you look at examples number 1 and 2, they are equations that we're going to try to solve using inverse operations, operations that undo each other. So if we look in the first one, we have x minus 7 equals 15. We want to get the x by itself, so this negative 7 or minus 7 we need to undo. Well, the undo or the inverse of subtraction is addition. So we're just going to add 7 to each side, because what you do to one side of an equation, you must do to the other. You may be comfortable by drawing a line through your equal sign. Totally up to you to go ahead and do that. Since these are inverses, you have a negative 7 and a positive 7, they're going to cancel each other out or undo each other. All that's left on the left side is x, and when we combine like terms or add these like terms, you're going to have 22 on the right. Therefore, x is equal to 22. Just by using inverse operations, we're able to solve this equation. Give number 2 a shot. Find the inverse operation of adding 10. we should be subtracting 10 from both sides because the inverse of addition is subtraction. Whoa, I don't know what just happened there. These are inverses, so they're going to cross each other out, and we would have x equal to 57 minus 10. You can think of that as 57 plus negative 10, since we're always adding, but you have to keep the sign of the 10, which would give me 47. Easy. Inverse operations undo each other. I'm going to zoom out and zoom up to the top of the next page. Okay. If we're looking at these two, there's still one-step inverse operation questions. Right now, 8y, since 8 is the coefficient of y, we have multiplication going on. Okay, two mathematical things smushed next to each other indicates multiplication. Now, this is actually kind of interesting. This is because back in the day when you were in elementary school, you did multiplication like this. 3 times 6. Then when you got to maybe middle school, you started doing stuff like this with the little dot. 3 times 6. Well, mathematicians are super lazy, so we decide to just stick things next to each other if we're multiplying. But all of a sudden, that looks like 36 instead of 3 times 6. So we'd put parentheses around it. Well, the same thing happens, but when we're using letters, it gets confusing. If I do 3 times y, that looks like 3xy. I can't tell the difference between the times, so again, we switch to the little dot. But because mathematicians are lazy, we just started smushing those two things next to each other. A number and a variable smushed next to each other indicates that there's multiplication going on. So if we look at this example again, we have 8y equals 72. That's a multiplication question. So to undo it, I'm going to divide. Now fractions are division, so this is actually telling you that I'm using division. Inverse operations cancel each other out, and we'd have y equal to 9, 72 divided by 8. Inverse operations. Since I just told you that fractions are division, what operation am I going to use to undo this divide by 4? I am going to use multiplication to undo the divide by 4. And what I do to one side, I have to do to the other. Multiplying by 4, I'm going to end up with k equal to 13 times 4, which is 52. Consult your brain or your calculator if you don't know how I got 13 times 4 equals 52. So it's important to know about combining like terms and inverse operations to get us to solving equations. Now, the way that we solve equations at Mesquite High School, it's totally acceptable if you do what you did last year, draw a line down the center and start using inverse operations. However, if that never worked for you, we have a method that we use here called the box method. Okay, the box method kind of will remind you of when you learned about fractions way back in the day with parts versus whole. But let me show you an example before you write it out and decide that you like the old way better. So step 1 is going to be to distribute if needed. We won't need that today, but that is step 1 always. Step 2 says to set up your boxes and drag and drop using inverse operations when needed. Okay, we're still using those inverse operations we just went over. Step 3 is to combine like terms, CLT for short, which is adding along the top row of your boxes. Then we're going to isolate our variable. This is typically with division. And last but not least, we check our solution because we're good students and we always want to check our work. Okay. Number 5, put your pencils, pens down, just watch the video for a hot second. I want you to watch me do this all the way through. I check and see if there's any distribution. There's not. So I'm going to draw my line just because I know most of you will like that. I'm going to set up 2 boxes. These boxes have 2 large rows and you count columns. This first side should be all x's and this should be everything else, all the numbers. There is only one x term in this top equation. There are 2 everything else terms. There are 2 terms that are considered constants. Okay? So when we're setting up our boxes, the x side is only going to have 1 top box, and the right side with everything else is going to have 2 top boxes. I've completely set this up. I have a top box for each piece of my equations. Doesn't matter how many pieces you have. You could have 5 boxes up here. You could have 1 box, as long as it's organized the correct way. Then you start dragging and dropping. I'm going to drag and drop this 2x into its box. Easy. What do you notice though about when I drag this -7 to its box? It crosses that center line. When it crosses the center line, I'm going to have to use inverse operations, so I change its sign. I use its inverse, or its undo. When I drag and drop the 13, does it cross the center line? No, so I just drag and drop it like normal. Remember, using inverse operations when it's needed, that's when it crosses the center line. Step 3 said to combine like terms, which is adding across the top. Well, there's nothing to combine with 2x, so I'm done. And 7 plus 13 is 20. I've combined like terms. Divide both sides to finish isolating the variable. Whatever the number is in front of the variable, so in this case 2 is what you divide both sides by. And you're left with your answer. X equals 10. We'll do one more example together before I'm going to pause the video and fill in number 7 and 8 on my own so you can just see how it would work. But number 6, a lot of people would be frantic about because there's a fraction, but I'm kidding you not. This is so much easier with this box method if you follow the steps. First step is to draw your line and set up your boxes. We always have a box on one side with 2 rows and a box on the other side with 2 rows. And we count. There is only one term with an x on it, so the first side only has x's. There are 2 terms that are considered constants or straight up numbers, so the other side has 2 top boxes. We play drag and drop. Drag and drop doesn't need to change because it didn't cross the center line. But when I drag and drop this one, what should I change it to? Its inverse, which is -15. Inverse operations. Drag and drop, nothing changes. I combine like terms across the top. This is 1/3 x, and this is -15 plus -15. That's -30. Remember, you're always adding. You might be adding negative numbers, but you're always adding. Now, I could use the inverse operation of 1/3, which is multiplying by 3, but in a panic, I can always just divide by what number is in front of the x. So I'm going to divide both sides by 1/3 so that it undoes the inverse of that coefficient, and I'm going to end up with -90. -30 divided by 1/3, or -30 times 3, is -90. And I have my solution. Okay, I'm going to pause the video right now, and you should probably pause it as well. Try to do number 7 and 8 on your own, either using the box method or what you remember from last year using inverse operations, and we'll check and see if our answers are correct. Hopefully you paused the video and tried both of these problems. Here is my work, which you can pause again and look at and see if you like this box method. It will solve any one variable equation that you come across in this class, no matter how complicated it gets. We will continue to explore this box method throughout our time looking at a unit of solving equations. Thanks for watching. Enjoy the rest of your day.